Cyber Quarter, I would like to welcome you all to this workshop. I would like to take this opportunity to thank our funders, European Union, Marches Lab, Midlands Engine, University of Wolverhampton, Hereford Council, and Skyland Park. I would like to now introduce our esteemed speaker, Professor Shujun Lee. Professor Shujun is the Professor of Cybersecurity at the School of Computing, University of Kent. He is also the Director of the Institute of Cybersecurity for Society. Before I hand over to Professor Shujun Lee, I would like everyone to know that we will be recording this session, so we ask everyone to kindly keep their videos and microphones switched off. If you have any questions, you can add to the chat box, which is on the right of your screen, and Professor Shujun will look at these questions and answer them at the end of the session. I will now pass over to Professor Shujun.
Okay, thanks for the introduction and thanks for inviting me to be here. And let me redo it because I want to share with computer sound. Sound open. Yes. Okay. Thanks everyone. So good afternoon. I think it's afternoon, right? Yes. And so again, it's my pleasure to be invited to give a talk. And my pick of the topic is privacy through the lens of data flows. And this is part of the research I'm doing for an ongoing EPS funded project. So we have a bit more details later on. And so largely the talk will be in two parts. So in the first part, I will try to do a pitch and of the complicated nature of privacy in the cyber physical world, and looking at how we interact with other entities and who might see our data and in different ways. And then I will move on to look at if we can do something with it. And one of the approach we are currently looking at is to see if we can actually use the data flows and to investigate this problem and hopefully produce a better solution for that. And okay, so let me start the first part. So it's better general discussion about privacy in the cyber physical world. And so I want to start with generally speaking, if we think about our data on the internet or the web, and we will see there's a lot of data with you know about a lot of things about our machines, about our operating systems, and also sensor data, and not just on mobile phones, because our computers these days also have a lot of sensors as well. And of course, our web browsers actually store a lot of data about us, like history and cookies and so on and so forth. And of course, nowadays, and we can't live without web browser extensions. And so web browser extensions will extending the feature of web browsers, and they also actually create more entries where our data will sit, and which can sit within the web browser extensions and could be in the web browser itself, but could be also online depending on how the web browser extensions are designed. But anyway, so all of these things sounds very kind of local. You know, you may feel, oh, this is more about data about my machine, or it's on my computer and so on. That of course also had the privacy concerns, but this seems to be more or less more under control. You might have this feeling, although this feeling might be misleading. But what I actually want to look at more beyond those more localized data on our machine, about our machine, on in our operating system or in web browsers, and it's about something we all talk about these days. It's about something called UGC, so user generated content. And for user generated content, and so they are quite I broadly split them into two categories. So one category is about profiles, and we all create a lot of profiles online, and they contain a lot of personal data, and largely speaking, profiles are mainly about our personal data, and names, faces, and address, gender, and this demographic information, which are important. And in addition to the profile data, and we also do a lot of activities online, and so there's a lot of online posts and comments, reviews, ratings, and other activities like likes and the fact of you used something, sometimes also go online. And many of these actually can contain a lot of personal data. And in many cases, they are linked to profile data, so you don't normally or you often don't post anonymously, and you have actually post under particular accounts, and which then has your personal data and sometimes linked to your personal data. And these personal and also the sensitive data and of ourselves included in UGC, and clearly is a problem. And this is where the privacy often really concerns really arise. And the more alarming fact is about often we actually may not actually have noticed what we did. We actually shared a lot of information. We felt we probably didn't, but actually we shared a lot more than what we expected. And to prove this is the case, and many people actually had many proofs, and this is one of the best proofs I really like to show during my talks. And so this is not very long video, 2.5 minutes, and it's called the Belgian Mind Reader, and some of you might have watched it, but some, I believe, may haven't watched it. So let me think, how should I, because I'm sharing my PowerPoint. So let me open this video in my web browser, and then let me share let me switch my screen sharing so that you can actually see the video in my web browser. We stop sharing. We switch sharing to my web browser. Switch on this web browser. Yeah. Can you see my web browser?
Yes, we can.
Yeah. Okay. And I will start showing the video, and hopefully it's not too laggy, and hopefully you will enjoy it. So I will resume after this video finish.
Dag Fien. Dus gewoon. Ik zie in school tegen Antwerpen.
Ja,
Insecten.
alsjeblieft.
Ik voel 2 insecten op je rug. Kan dat?
Ja, vlinders.
Slovenie?
Sorry.
Een moto. Oranje.
Pas erop.
Zenit.
Oui, oui, bien.
Je hebt een vriendin. Julie de...
Ja.
Een boeiend liefdesleven. 3, 4 zelfs.
De vierde, daar zwijg ik meestal over, dus dat weten niet veel mensen.
Hoe is het met je spierscheur? Maison rouge, balcon blanc. Ja. Ik zie geld, ik zie transacties, maar kent je rekeningnummer van buiten? Ik denk dat ik het wel weet. Er staat wel negatief op je bankrekening.
Ja?
97. Last month you spent €200 on alcohol. Vorige maand €300 aan kleding gespendeerd. 8.
Ja.
5. Voor een huis dat van eigenaar gaat veranderen. €795.000.
Ja, eigenlijk.
41.
Ja.
Is dat juist?
Ja, dat is juist. Oh my god. Oh nee. Ah, dat is niet hoe eng.
Okay, so hopefully you enjoyed that video. So let me switch back to my slides. Okay, let's see. Okay, so this video, of course, as you can see, shows how much personal data actually is publicly available actually online, so that actually other people can actually see a lot about our personal lives. And however, well, I talked about data of ourselves, but if you think more about what we do online, and the personal data and the sensitive data we actually put online, it's not just about ourselves, but also about other people. And then in this case, if we don't even know, our own data got posted by ourselves, and it will be even harder for other people to notice or have even any way to know that their data is posted online by other people. And in some case, the other people might be informed, and they may feel, reluctant to actually say no, and will just accept it. And in general, you can control what others will share about you. So that can be an even bigger problem. And a very simple example, and this is a post I actually posted in 2020, 2022, 2021. And so you will see that I actually leaked information about my two collaborators, what they are pretty much working on. And also you also see actually one of the collaborators' Twitter account appearing on the right-hand side just below me. And of course, this is not a real leakage because this is about a research paper, and we have agreements of publicly promoting the information and the collaboration between the researchers. But if you think about other things, and such information can be disclosed and without the awareness and consent of other people. And this can include a lot of information. And if you are interested, and you could also do some online exercise after this talk, and you can try to search for vehicle registration mark or the number plates, the number on the number plates of vehicles, and you can use something like my car or some other keywords to find tweets on Twitter, and you can look at what information people actually disclose about themselves and about other people, and you will see how really big the problem is. And this is just one example, of course, about one type of particular information, which also leads to other leakage of other information as well. And if you think further, and if you see that even some very simple data, you might feel, oh, it's just my data, but actually it's not really just your data, like our names and DNA data, and they are really about the extended families. And if you disclose your surname, and depending on the context, and often your relatives and your family members' surnames also got disclosed. And if you actually disclose your DNA data, and that actually can lead to disclosure of many of the people who share some part of the DNA with you. There is actually a case and about even unknown people, and could be their property could be compromised because somebody who completely have no connection with the victim actually has the DNA data put online and made accessible to others. And you can also think further about it's not just about the people we know, actually, it's also about the people we don't know, and like bystanders. So this is an image which I found on a very large, very popular image portal. And you will see that this is a car, and actually the number plate is clearly visible, and all the people are clearly visible, their face, and they are minors as well, and even babies. And it's just a lot of information about a lot of people, and also looking at how this picture is taken, and you will see that the person who was taking the picture clearly didn't get consent from any of those people in this image. And this image clearly went to the public domain and without any even consideration of the privacy issues. And if you look at the actual license terms or general the terms and conditions on the website about the image, you will see they did mention something, but they definitely never mentioned about the privacy of bystanders, which is also quite worrying. And of course, and if we really think about who are really getting our data, and of course, in terms of UGC, and there's a lot of more highlighted ones, right? We talk about every day: online social media, microblogging, chat room, instant messaging, web forum, image or video sharing portals, search engines, and so on and so forth. And of course, they are already a very big portion of the website we normally visit. But if you really think more, you will see that it's not really just limited to those familiar type of websites. It's really now became any websites or almost all websites with some feature of supporting UGC, which can include many different things: online shops, app marketplace, online book, news outlets, online dating, e-petition, online maps, because we leave comments, we give ratings, we leave traces, and so on and so forth. And there are a lot of UGC actually on those websites, which you may not immediately think they are a problem in terms of privacy. And a quick example, Google Maps. And so this picture is my location history in the past at a particular point, and it's a few years ago, I think. And you will see that Google clearly remembered me well about where I visited, and of course they also know the time. And to be frank, I even didn't remember, this full history myself, because my brain is clearly not the best, machine or something to remember those things. And in addition, in addition to all the data we were sharing and actively with online services, and actually online services are also very actively nudge us or ask us to share more data with them. And so in 2021 last year, so we published a paper, and as part of the project Provot, which is the project I will talk about later on as well, about the data flow methods. And we basically looked at how these different kinds of data sharing nudges used by online services and really had effects on disclosure of personal data online. And so this is basically meta-analysis and a literature review together. So the literature review is about looking at the many different papers, looking into this particular research topic, and the meta-analysis is about combining all the statistical evidence together and see if actually we can have a enlarged set of evidence about this problem. And our findings are not surprising, and we actually observed a significant small to medium-sized effect of the nudging interventions on disclosure. It means, in addition to what we, directly shared without being nudged, and we also shared actually more. We are also likely to have shared more data because of those nudges, and those nudges can be not very visible, and you may not feel it. And the second key findings shows that many of the different ways of online services, nudge us to share data, and there's no particular, difference about the effects. So meaning that all the different ways the online services are using to nudge us to share more data, and more or less works, which then will make the privacy concerns an even bigger problem. And further, if we think further about online services and other malicious third parties, actually can also get more data about us from what we shared or what they get or what they nudge directly out of us, because there's something called the privacy inference attack. And there are many of these kind of attacks. So this is a screenshot from 2021 literature review paper, which look at how the privacy inference attack, can be classified, and you will see that there are many different ways. And for other, for the data consumers, and to actually to infer more about us, even if we haven't shared them directly. And if you then go further, you will find out, well, many online services are not too bad. They are doing something, trying to protect us using so-called PETs, or privacy-enhancing technologies or tools, but they can fail very badly. So one example is Google Street View. So this is the example, and I can't show you the actual image because I don't want to show the image with a privacy problem and in such a talk about privacy concerns. So I actually did the pixelization of the image to hide properly the faces of people. But if you actually go to this particular image, which published in June 2018, you will see all people's faces are clearly visible and without any anonymization, although Google Street View is supposed to have done that properly. And look at how long this image has been on Google Street View. And similarly, another image which I found, and it's in Canterbury, actually my town, and one of the motorcycles in this image and the number plates is clearly visible. So because it was not properly anonymized, although they are supposed to do it. So those paths can fail, even if online services are very ethical and try to protect us and behave very, honestly, but things can go wrong. And they don't often fix it, very quickly. If you look at this image, you will see this is already more than 10 years, right? And they still haven't fixed it, or they even didn't know it. Okay, so hopefully you agree with me that the sharing of personal data online and partially and in the physical world, because if you look at Google Street View, it really look at our physical activities rather than our activities online. And then if we really think deep about where are our data, really, where are those data? And you will probably start feeling that seems to be quite unclear. It's on our device, on the internet or the web, which online services, where exactly, what kind of data? Do you actually know, or do you care, or do you actually already forgotten? Because when you register the account, you put a lot of data in it, and then you use it. You may actually then abandon the account, or you did something else, you forgot what you did, and then data got leaked. So this picture actually shows, a lot of large data breaches and hacks, and you will see that so many different services got data hacks, and you could actually have data leaked and to other bodies which you didn't mean to share and without knowing it. And if you think about the devices which might keep our data, and then think about IoT, Internet of Things. Internet of Things really are now everywhere. It's not just about computers, it's about all these kind of devices which can be in our environment, the physical environment, and you may know, you may see, and you may not. And many of those, of course, use cloud, meaning that even if you see them and you don't necessarily know where your data is. And of course, among many of these IoT devices, and many of them are physically stored, located in a particular place, many of them are moving. Mobile phone, camera, and things on sensors on airplane, on cars, smart watches, tablets, and even laptops, right? And they're all moving. So that even make it even harder to think about where are the data really are stored, when data got captured, and so on and so forth. And that makes things even more complicated. And hopefully you agree with me. And give you a few more examples about this complexity of this kind of data sharing in the cyber physical world, like COVID, contact tracing, and we have a mobile phone. We go out, we have a walk, we bump into somebody we don't know, And then there was some data exchange between those people. And then, of course, there were data also shared with authority because they need to do the tracing. And then there are debates between centralized and decentralized methods, which will mean different way of sharing between different bodies on different kinds of data. And another example would be about CCTV surveillance. And if you think about how many CCTV cameras we often, encountered in the real world, and also how many CCTV cameras we probably didn't notice, and then think about what that really mean in terms of our privacy, and in both physical and cyber world, because those cameras are largely digitized, meaning that they use online storage, cloud-based mostly, and to store the data. And you could also think about simply doing nothing but sitting in a tube train, like this very famous this Russian fun face example. So a journalist went into a tube and of St. Petersburg and tried to take pictures of people sitting there, and then use those pictures and then try to match the profile images on a social media website in Russia, which is the wiki.com, which is more sort of online social media for dating purposes as well. And he actually can identify a lot of people, actually, profile actually on the website. So that also actually caused a lot of the issue of the public, the physical space, and got connected with the online space, and which can be completely unexpected, right? Because you may feel that I just create an account on social media, and why that would cause concern for anyone, I don't know, right? This doesn't seem to be the case according to this experiment. And I hope you agree with me that at this point, you will see that in this cyber physical world, and our data is really going from us and from others around us, either people we know or people we don't know, and to many different places. We may know, we may not know, and for many different reasons: legal, business, or we just share ourselves, or it just got distributed by other third parties, and so on and so forth. And so, if you look at this landscape, and I hope you agree with the conclusion I show on the slides, which says basically in the cyber physical world, if you think about privacy, and there seems to be a way of describing it as a lot of data flows from us and other people to many data consumers who could be visible and known, and can also be hidden and unknown. And that is the big problem, and I hope that we can do something and to address. Okay, so this brings us to the second part of the talk about the ProVault project. And I already mentioned the ProVault project in the first part for this systematic data review and meta-analysis of the data sharing knowledge. But this project actually is larger, and we did something else as well. The project, you can read the full title, and it's mostly about privacy-aware data management, and looking at particularly layer travelers. And so our idea is to see how we can manage the data to maintain the privacy, or at least to bring awareness to travelers, but also considering how to maintain or improve the travel experience of the travelers, so that you don't just over consider privacy, so that you basically lose the point of human travel. Right? So the project started in 2018, and the current ending date will be in September 2022, and no, but lasting until September, before years. But currently we have some because we got affected by the COVID, particularly in terms of recruiting and running experiments. So we are currently planning for extension, so which is hopefully will be approved very soon. And so the website, if you want to have a look at the details, so proval.ac.uk. And so the main partners are these universities. I will show you a better picture, so you actually see things a bit better. And okay, so this is kind of a diagram showing the project team at a point in the past, and also shows part of the team, because the team has, kept evolving and changing. Basically, some people leaving, some people joining, and like we have two research associates at the top, and now both lecturers, and we also have part-time research assistant associate joining us, and also we have people even moving, like one of the co-Is moved from Warwick to Nottingham Trent University, and so this is just a sort of a snapshot of the project at that particular point. And you will see that multiple universities involved, and what is particularly interesting I want to highlight is that if you know some of those people, if you look at the title, subject in terms of what they do, and so this group of people actually is highly interdisciplinary. And we have many from computer science, we have people from tourism, and we have people from business, ecology, and law. And I hope I will later also highlight a bit more about these different disciplines that are very important for addressing the problem of privacy. But I think many of you probably already know from your own experience about the privacy problem is actually highly interdisciplinary, and it requires an interdisciplinary approach rather than just a computing approach. Okay, so to quickly summarize, to quickly actually explain the big vision of the project, and the big vision of the project is explained in the paper, and you see the detail at the bottom, and which is second year after the project started. And so the vision of the project is basically to create a user-centric system, which effectively, if you think that it can be a mobile app, the user use. And we want this mobile app to be so-called serverless, which means we don't rely on a new company and to run a servers, and then you install the app, and the app talk with the web server of the company, and to get this problem solved. So we want it to be serverless, meaning that we produce the app goes to the app market, and the user download it and use it, and then the user does not actually directly report to us unless they explicitly decided to do so. So the whole app is purely on the user side, based on the client function, and stored on the client. And of course, user can choose to store it on the cloud, cloud storage under control of the user, or so-called personalized data storage solution. But this is all user's decision, not the company solution if the company runs a service to enable the solution. And so the idea, of course, is for this app to produce enhanced awareness of the privacy problem in terms of private personal data shared with other entities and causing potential privacy concerns, and then moving on to have more active nudge so that user knows what to do to improve the privacy management, so that they can balance the privacy protection and also the travel experience they want to enjoy, because which would include sharing some level of personal data with some people to make sure that you enjoy the travel and also share with people you want to share the experience with. And so this app, if you look into the app and look at how it works, and so what we want to do is we better want to have some kind of a profile of the user, so we know what kind of user this particular user is, and then we can look at the assessment of the data sharing with different entities, and then we hopefully will give some nudge which personalized to this person, so that the person can actually adapt the behavior to better protect themselves. And a core part of this vision or this design is this box. We call it ontological knowledge, a knowledge base, and where we need to have a knowledge base which describe the data sharing and also the world, basically the cyber physical world of the different entities and of the different kind of data, what data is shared, so that we actually can do the privacy assessment properly. And this is the main actual proposed topic, but this is a topic we propose to talk today, and which is about data flow. And let's have a look at this in a bit more detail. And so our approach is to look into this problem from the concept of data flow ontology or data sharing ontology. So what that ontology captures is, if you look at this diagram shows the different type of entities, and you have a person, you have data, and you have a different piece of atomic data come together to form data packets. And then data packets are basically shared or required by services. And then the services can be physical and cyber. And so you see that the left-hand side is physical and the right-hand side is cyber. And you have things which are hybrid, like the data can be both, and the data packets can be both, and service can be both. And then, of course, you have eventually the service actually, is owned or provided or supplied or organized, belonging to an organization, which then, of course, also have people behind. And then on the cyber world, you also have the online account, you have online groups, and which actually also consume or share data. And so there are a lot of then relationships between the different entity types, and which then will trigger the different potential or real data flows. And if you look at the person entity type, and so there will be many entities or many persons, and our approach is to look at a particular individual and as me, as the person we care about, and this is reflecting the user-centric design of the app I talked about it before. So for this current user of the mobile app, and that person's data is what we care about. And of course, there are many other people we need to consider, because those people can be the consumers, and these people can also be the data disclosures who actually disclose the data of this person, me. And if you look at and think about this data flow graphical model, and you will see that all the edges will represent data flows and or relationship. And of course, we look more at data flows which are triggered by the relationship. And so the data flows edges will need to be data specific, because we talk about one particular piece of data flow from one entity to the other entity, and you don't simply say there is a data flow, and without talking about the data. And all the so the graphical model actually also matters in terms of time, because so first the data itself can have time, make it valid, expired, useful, not useful, and so on and so forth. And also the sharing, of course, also depends on time. And so a lot of things actually are related to time, meaning that we also need to consider the time effects. And finally, as I already said, the data flow can be real ones, which we observed, like I shared a piece of data with Google Maps that is real and that happened, so we record it as such. It can also be inferred and potential data flow. And in general, any data with beyond the services will be mostly inferred, and particularly in the physical world. in the online world, if you see it, that it's real. But if you don't see it, it doesn't mean it's not, shared with somebody who might have a possibility to see it. So these different aspects of this data flow ontology hopefully give you a flavor of this. Is actually a bit, it can be a bit complicated. So now let's look at the size of the data flow graph. Although this is just about a single individual as a center, but if you really think about the number of nodes of such a graph, and it's actually quite large. So you have only one node, which is about me, the center. But then you have all the different data items and data packets which are about me, which are actually quite a lot because we have a lot of data about ourselves, particularly because our, the life patterns, the history of our life, also used for data points. And think about all the people our data can flow to, and that could be anyone. If you think about it, you post some data on a particular website and made it publicly available to anyone who can visit the website, right? That can immediately create, in principle, billions of nodes. And of course, when you actually model the graph, you probably want to use a single node representing anyone rather than, really have all the billions of people modeled. And if you think about all the physical and online services our data can actually flow to, again, that can be quite a lot. And of course, then think about the organizations behind the services, which is often more than the number of services. And if you want to get some kind of a flavor of how many, and one easy way of doing it is to look at our password manager. I hope all of you are using password manager to some extent. And you can think about how many entries you have in your password manager. Each password manager entry and represent normally an online service. We have some data which we'll share with them. And if you think about the number of edges of such a graph, and that will be huge because the node is large. And then if you think about what entity can be connected with what entity, and in terms of data flow, in terms of relationship, and actually it can be a lot. And also don't forget, between two entities, and you can have multiple edges, because not just a single piece of data can flow, and time matters, remember? And so that means there can be, so this actually can be a multiple edge graph rather than just a graph with single edge between any pair of nodes. And to think about the number of edges and in such a graph, and you can actually think about what data you have in your Google account. And you will see that the amount of data we share with Google, and it tells you the amount of potential edges you will have between you and Google, either directly or indirectly. Okay, so if we have, assuming we manage to have such a complete or even incomplete data flow graph of a particular individual, and we actually can do a lot of measurement just to see what we can learn from such a graph. So for instance, we can measure order degree, meaning that the amount of data we share, because it's about how much data we actually share. And of course, you normally look at time window because time matters, as we said before. And if you look at average nodal degree, and of course, looking at the data consumers, you don't look at me, because me is the data owner. And then that gives you some idea of the average amount of my data disclosed to an average data consumer. If you look at node and the link connectivity of the whole graph, and that will give you some idea of the number of essential data consumers or data sharing activities, which actually are crucial in the whole space. And if you look at the centrality metrics and among those data consumer nodes, and you should be able to identify the major and the most influential data consumers, and which are potentially very hidden ones, meaning that you probably don't know them. And if we look at, for instance, the longest passes and originated from me, and that potentially can allow you to identify the most hidden data consumer because it takes too long to reach, which means that it's more likely you won't be able to even think about it or imagine about it. And of course, we can also look at the network type of the whole graph, and so we will have a better understanding of what kind of data sharing patterns of this individual. And some of you might have heard of the term small world network, skill-free network, and some other network, which then can tell us something about what is the nature of the data flow graph of an individual or many individuals. And there could be other metrics. And in addition to doing this kind of simple metrics of the graph, and we could actually also look at privacy issues, which are represented as some topological structures. So for instance, if we think about a specific data item or data packet, and if that has a particular privacy issue, and then that is often something I call it a data flow path. So you have a path in the graph from me all the way to a particular data consumer, and that itself can be a privacy issue. And like I share too much of my birthday information with Google, for instance. And if you think about a group of a problem, a type of a problem, and which could be about mostly about a particular data type, like do you share too much information about your birthday or your name, or home address, and so on and so forth. And because many data consumers can receive it, so you have multiple passes. But if you put those passes together, and they should have some kind of common features, so this set of data flow passes sharing some features can collectively define a particular type of a privacy issue. And if you look at more data types and packets, and like this person shared too much information, when you consider all the different data this person is sharing, and then you can have set and offsets, because each of the data type will have a set, and then you have many different data types, and then they will cause a set of sets. And depending on what you are interested, and then you could actually use some methods to detect this kind of common representative topographical features to actually describe or potentially detect these issues, which then, of course, can be used for awareness and protection purposes. And let me give you 3 examples, and just to give you some flavor, concrete flavor about how these kind of topological features and can mean something more concrete. So the first example is about data sharing with potentially unknown consumers. And so the idea would be, if we make a hypothesis which says the longer the data flow path, the length of the path is between me and I've got the data consumer, and we can see the more likely the user is unaware of the data consumer. And then you can look at the risk assessment, right? Meaning that you could have a metric saying that the better the length, which then will be processed by a particular function, and you will get a risk assessment. And you can visualize it, obviously, and you can highlight in the length if you don't want to highlight actually the exact path. And if you want to detect, and of course you can, a naive method would be you can set a threshold, and then if the path length or the risk factor is above the threshold, then you raise alarm. So at the bottom, you will see some examples, like the left-hand side, you have some data which is shared with a particular servants, which go to another servants, and eventually go to a particular organization. And although the servants itself seems to be more belonging to the provider 1, but through servants 2, it also go to provider 2. So in this case, you have this data flow path length 3, and which is less visible to the user than provider 1, because that only have the data flow path equals to 2. And in the right-hand side, this is the case of online social media. So if you share some information with with a group, and the group can share with another group, and then you have people who are not members of the first group, then but in the second group, they can see your data, which is then going through a number of jumps, and then if you do the count, and that can be up to the length equals to 6. And the second example is something I call indirect data aggregators, and which of course potentially unknown. And again, this is about if we can see a tree whose root nodes, so a tree in the graph, whose root node is the data consumer, and then you will see that the taller or bigger the tree is, and the more likely this tree is probably a super data aggregator. Again, look at this example at the bottom. You will see that my data and the flow through many different passes and also different type of data eventually all go to a particular supernode, which is the provider A, which is then, as you can see visually and topologically, and that is effectively a data aggregator. If the depth is very, very large, and this would mean that this data aggregator is likely to be unknown to you because it's too far away from you. And you can do something very similar to the first case. In this case, you could use the height of the tree, and then you can also particularly visualize the height, and then you can use the threshold to detect this kind of hidden aggregator looking at the height. The third example is about data sharing with too many consumers. So that is interesting, a tree, and on the other way around. So if you have a tree whose root nodes is a data, it's a particular piece of data, and then you will see that particular piece of data can be shared with many, many entities. Then you will see a tree, and the data flow from the root nodes all the way to many of the nodes. And in this case, you will see that the more, the larger the tree is, and then the more data consumers, indirect or direct, you will have. And then you can also use this as a way to detect this kind of oversharing and for this particular data item. So these are the three examples, and showing that how the topological thinking about the data flow graph can actually give us some ways to both understand, but also potentially detect, and so eventually to help you to know or to take actions and about protecting the privacy. And with data flow ontology, and we can also easily make it computational by defining rules, and we can then use queries which can automatically discover some of those problems, like what we actually implemented. So we actually implemented a number of examples using OWL, and then use some software to implement the automatic reasoning, and meaning that you don't actually need to you don't need to manually check the very large or huge graph, but you can do it automatically to identify the problem, and then you can actually probably show to the user. And so so what we have talked about is the first version of the data flow ontology we developed and published in the paper. Yeah, I think I showed the paper on the first slide about the HSSS 2020. And then we developed this ontology further into a second version, and mainly to add something we call value flow. So in the context of Pervault, we are looking at both privacy and value enhancement, right, about the travel experience. So we want to consider both privacy and also the value you get by sharing data, because often you share data to get enhanced personalized services. You share data to get rewards, like the people like your pictures, and interacting with your family members. We have a better happiness, and all of these things. And so we feel that is important. And in some other cases, also you also have monetary or non-monetary rewards, like some of the providers will actually give you a discount or give you even cash return. So to capture these kind of returns, which are highly related to why you share, and if you actually consider this sharing is a problem. And so we added this value flow. And so the value flow is a condition, it's not a condition, it's a consequence of the, in some cases, the condition, in some cases, it's a reason or condition, in some cases, the consequence of the data sharing. And so this paper was recently published at the Security and Privacy Magazine journal. And so if you search for the name, you should be able to find it. And but I'm happy to share the slides so that you can click the link to find it. And this second version, of course, is just started, so there's still a lot of work we need to do. And in this value return, and if you think about it, and you will see that psychology matters because it's about how people think about the value and how they then decide if they should share and for what they will be getting. And the business matters because this is clearly a business model in it about how online service providers can use value to tailor and to modulate and the user's behavior, their customers' behavior. And when monetary or generally when value is involved, and that also matters, this is basically becoming an economic problem, and which require expertise from those disciplines. And as I said, so the data flow graph for us is about a user-centric graph, meaning that we need to look at the personalized data flows. To get a personalized data flows, and there's no other ways rather than build an app which each user use, and then the user will let the app to know and what data they're sharing. And so this is what we are developing. We have been developing, and it's an Android app, and we have some initial features added, and we are still in the process of refining it. But the ultimate goal is the app will allow us to collect the data we need to construct an incomplete personalized data flow graph. And the reason why it's incomplete is because there's no way for us to capture all the services and all the data the user is using. And not just about the physical part can't capture it easily, but about the online part, there's so many services, and there's no way for user to enter all the data into the single app so that it can capture it. However, even if we have an incomplete data graph, we can already do something, and which will be probably much better than having no knowledge at all. And in here, similarly, psychology, business law, and ethics are all matters because we have to carefully consider how we develop the app to make sure it's ethical, and to also make sure it's legal and like data protection. And also, of course, we have to consider how we can work with users and also the different services to make sure we can get the data. And this is actually one of the key challenges of our current development work, because many of the services are not collaborative, so they don't give you the data, not even to the user. So we actually need other ways to overcome this lack of APIs, for instance, for users to get data for themselves. And coming back to our vision, and we want to complete the app, we want to have the personalized data flow graph so that we can study the behavior of users, we can study the problem, we can provide solutions to users. And the ultimate goal is that we hope to have the app with the full features, and then we can run a field study and one or more, and with the real travelers. And originally we planned to do in 2022 summer, but now we look like we probably need to postpone it until probably early 2023. This is why we are planning for extension. And then from the study, that we can start looking at the personalized data flow graph, so that to see if we can understand more about what we can do to help. And so I think I'm almost on time. So, and finally, and hopefully you still remember a little bit of some of the things I mentioned. But let me give you a little bit summary of take-home messages, so that you can bring this single slides back and think about if that is something you can do or you are interested in, planning your research. So the first point, and it's about the data privacy problems, can be studied as a data flow graphs. I hope I convinced you that this is the possible approach. And the second point is about such a data graph are personalized by nature, and because we really need to consider me, because when we talk about personal data, and you always have to consider the data subject according to GDPR term, and that requires the data flow graph to be personalized. And that requires user-centric tools to be developed to engage users. And because you can only get the data from the users, and you can't get it from some providers, as I said before, because they are largely non-collaborative and they don't come together. And also, they, in principle, should, of course, not share with you if you became a service provider itself without user consent. And I hope I also convince you that to study this problem, and we need researchers from different disciplines, and I mentioned psychology, business law, economics, and ethics, and of course computer science, obviously. So I didn't list it, and engineering, and maybe others. And so this is something really require interdisciplinary approach to address. And finally, so ProBot is still ongoing, and hopefully the extension will be approved until next year, and so that we can continue to work on it, and we welcome different type of collaboration, and you can be participation of the field study. You can help us do the testing, and of course, if you are interested in doing research together, and also we're more than welcome and to discuss the possibilities. And yeah, this is largely the end of my talk, and I'm 4 minutes over, I think, but hopefully then this is not too bad. And hopefully this single slide gave you a bit of high-level ideas, and which you learn from this 1 hour long talk. Okay, thank you very much. And any questions, please do ask.
Thank you, Professor Srijun. This was really nice. I was really intrigued by the whole presentation. I have, at the moment, let's see if somebody posted, but I have questions of my own. So it's a mammoth task to deal with the privacy issues on the user-centric part. To begin with, it is very hard to handle, and the way you have described it in terms of data flow, it does make sense. What I was wondering, tell me if I got this wrong, you are putting this in an app form on the user side. And when you say it gives you a nudge, so there are two things that I had questions on. So when it gives you a nudge, is it telling you that you have posted something somewhere that is private and you need to pull it back? Is it telling you specific information?
Yeah, so let me clarify. So I think I could have plugged in something about what is a nudge. So that is quite an interesting research question by itself. So there are the very famous, there were actually a recent survey paper, I think it's a survey probably a few years ago, 2020 or 2019 probably, at the ACM transaction on privacy and security, about the security nudge, security and privacy nudge in general. So there's actually interesting points about everything is a nudge, if you really think. Because if you think about what we do with computers, so everything on the user interface, which either gave us information, which is the informational nudge, because it tells us something, or it gives us a recommendation, right? That would be recommendations, and you have other forms as well. So in a way, what the designer or the algorithm, if it is completely automated, decide to show on the interface, ultimately became some kind of a nudge. There's just a different level of you know, how strong the nudge is. So when I was talking about privacy awareness, it might mean that what we do is we show, we construct the data flow graph, we calculate some metrics, and we can show you the metrics, right? Okay, so the metrics will say, okay, you are among the most, you know, generous data sharer, right? You share data with everyone, with every service providers. What does that mean? Up to you. So then the user might decide, okay, well, I'm the one sharing too much because nobody sharing so much, they will change. Right? That would be just about awareness became a none. That is informational. But of course, you can also do something more specific. And like you could say that you actually share more this kind of data with that kind of particular service provider, according to your data flow, right? Graph. And you might want to stop sharing or sharing less, or you can share with more service providers so that you dilute the aggregation of your data. But then sharing with what service provider to dilute the aggregation require you to understand the network between service providers, because sharing with two services doesn't mean they are not aggregated, because if both services are owned by the same organization, they are still aggregated, right? So this is where you need to have some understanding of the business network. And this is another piece of work we are currently also looking at, which I didn't highlight today, but that is a quite important part, because we need to understand the servants and organization and this conflict relationship, so we know that what kind of recommendation we can give people, right? Like share with Google and Apple is fun because they don't share between them because they're competitors. But don't share with Google and maybe Microsoft. I don't know if they have more collaboration, but so that kind of recommendation could be done. And for us, of course, we are more likely to potentially more stay with the awareness bit because of given the limited time we have. So ultimately, the assessment, the factual side of information will probably become the nudge. And often they will indicate very obvious things you should do, right? Like stop sharing simply, or just pay attention to Google. That's all. Of course, how you pay attention to it is something else you have to think. Hopefully I answer your question. Yeah.
Yes. But the follow up from there is, for example, you know, the information like you mentioned, we saw in the video, which was really eye opener there. You do know your private data is out there on the social media, whether you talk about the Facebook was the #1 with the amount of private information that is out there. Now, when you put the onus on the users, whether it's in the form of the application that you are forming, you are asking the user to not, because now the social media is taking the Facebook or the WhatsApp. Now, when I'm sharing something on something like a WhatsApp, it could be an information that I do want to share very consciously. I am sharing with my family members, which can move forward if they try. I have no control of what my other family members or extended family members are doing. So that information is going out. On a Facebook, I am conscious it is out and still I'm sharing. So even with that nudge that comes to me saying that, oh, you have posted something on Facebook, I am still inclined to do it.
Yeah, correct. So this is a very, very good point. So this point is related to this. Let me go to the vision. So this is related to the preference management. So the preference management is basically about the profile of the user in terms of the motivation and the behavior of sharing in general. Like you said, it should capture intent. So basically, you could have one type of person, right, sharing some particular data on social media with anyone, right, publicly. That is fine, because this is this kind of user, and they choose to do so. And this could be considered so that when you actually assess the privacy, leakage or whatsoever, you could actually reduce that part or even completely remove it. So this is why you have the 3 and 4, which need to interact with each other. So this is why we also have a separate line of research about user profiling. So the user profiling allows us to capture what kind of a person this user is. So we have two different approaches of doing it. So one approach is using a mini quiz. We have actually a paper published at a different journal about using. We designed a longer survey, but we compressed it. We can compress it to a short survey with only 7 questions. And in principle, you install the app, you can be asking the 7 questions like over a few days, and then we get your initial profile set up. And then we can start observing your behavior, right? When we're observing your behavior, in principle, you can also ask your users, right? Is this what you mean to share? You can then remember that. You can tailor the profile, and then that can be considered in the awareness kind of assessment for awareness purposes, and so that will be tailored to this user as well, which means that exactly the same data flow graph for different type of people, and the message should be different. And of course, this can be very complicated because there's just so many different intent, right? You could have one intent for on a social media, you could have another intent for something else, which also depends on the data type. So this is why we actually found out that this just became exponentially increasing when you start looking at the whole stuff.
That's the reason you also mentioned it's an incomplete data flow. You really can't complete it.
It's impossible. It's impossible.
It's impossible.
So this is why we are going to more focusing on some subsets to actually more demonstrating this can be done for a subset. If then it can be done, or how this can be done for a large set, is a problem of open question, because it's very challenging to get the data already in the first place. Because I briefly mentioned about data online service providers are not collaborative, and mostly they create barriers for users to get the data, even actually. So because this is why many don't have APIs. They only show you on the interface. They only allows you to submit a subject data request, and via a very traditional approach like email, even post address, right? You post a letter to them, then it takes time to process, and so on and so forth. And so that is already a challenge, and this is also something we are looking at how to address. But in general, for this project, the main message we will be producing is about this is a complicated problem. We can do something with it, and the actual solution will require probably 5 to 10 or even 20 years, because it's a very complicated issue, actually.
Absolutely, because you have mentioned it will be user-centric and serverless. However, even though it is serverless, you are storing data onto the phone, because that in your diagram where it says historical disclosures, it needs to store some data on your phone.
Yeah.
Which is again going to take the power consumption and possibly the memory of your RAM and also on your hard disk or the
Currently, what we do is because there's no other ways you can store your data if you don't store it with a trusted third party. So currently, the current app actually supports local storage. It also supports online cloud-based storage, like you can store it on Google Drive actually, but in encrypted format, meaning that you actually have a key which encrypts the data, so that even if someone breaks into your Google Drive, unless they break into the key, so they can't get the data. So, but that is indeed another issue about the balance between privacy and also usability, right? Because you definitely don't want to have the burden of managing your data where you want to get the benefit. But this is also the dilemma of if you don't want to do that, you have to outsource to a service provider. Then which one you trust? That is became the dilemma, right? So,
but that's what the research is all about: finding new pathways, finding new ways. That's brilliant. I think we don't have any questions here, and I am quite satisfied with all of that. It's quite a insightful presentation, and it was nice having you deliver this. I think we can stop now, and thank you so much.
Yeah, thank you for the discussion.
Yes, it was lovely. Somebody's typing. Shall we just wait?
Yeah, let's see.
Okay.
Okay, that's thanks.
Thank you. Thank you, Thomas. Thank you, our audiences. I think it was really nice to have you here, and thank you. Thank you so much.
Okay, yeah, thanks. Okay, have a nice weekend. Okay, bye.
Okay. See you. Bye, everyone.
Bye.